Hi guys, this is a video lesson on the beginning of the law of sines. We're going to talk about this more on Monday. These are actually technically the little bit easier problems. We're going to talk about the more complicated one on Monday. So the whole point of this new chapter, if we think back to when we started trig, it was all about right triangles. SOHCAHTOA. That's what we can use in right triangle trig. So sine, cosine, tangent, and then their reciprocals, cosecant, secant, and cotangent. Those only work if the triangle is a right triangle. So what we're looking at today is what are called oblique triangles. That's a triangle that does not contain a right angle. So what we're looking for today is how do we solve for missing parts of these? And we're going to talk about two different laws. Today is going to be the law of sines. Tuesday is going to be the law of cosines. But we're going to talk about when you use which law. So the law of sines, as you see it in the blue box, it tells you that it's just really a comparison of the side to the sine of the angle. So they give you this proportion here. I'm going to suggest when we set them up, we're going to use this one. So this is the other way of doing it. This is the way you did it in geometry. You've actually done this before. So we're going to do this setup. The law of sines is going to work in the following types of setup. So if you look at your triangle and you fill in the given information, if you have side, angle, angle, or you have angle, side, angle, law of sines will always work to help you find anything that's missing in the triangle. So these two always work. It's this side, side, angle, which if you remember back in geometry, that spells a bad word backwards. That's going to be the difficult one. That's going to be a pain in our, read that backwards. The law of sines is ambiguous, which means it sometimes will work, it sometimes will not work when we have this. This is what we're going to talk about on Monday, so you don't have to worry about this difficult one yet. That's going to be Monday's lesson. We're going to focus in on the other two. All right, so to start this problem, the first thing you actually have to do is you have to draw out the picture. So we're going to draw a triangle. Remember, it's an oblique triangle, it's not a right triangle. And we're going to write in, this is going to be triangle A, B, C. And we're going to fill in everything we know. When you're looking at these first couple, since they're big letters and they have degrees, those are going to go in the angles. So this is going to be 64, and C is going to be 82. The little letter here at the end is telling you the side, and it's actually telling you which angle it's going to be across from. Since it says little c, that means it's going to be across from big C, so the 14 is going to go over there. So our goal in these problems, if you see the directions, it says that we need to solve the triangle. Solve the triangle means that we want to find all the missing pieces. We did this with right triangles before, now we're doing it with a not right triangle. Everything that's missing we're going to find. So, in order to do that, the first thing I want to point out is what allows us to know that we can use the law of sines in this. So if you look at the setup of this, where the position of everything is, we have an angle, and then a side that's outside of it. That tells me that this is an angle side problem, and angle side problems, if you looked back at the last page, we're allowed to use law of sines for. So that's going to be our goal. But before I use law of sines, I always like to find the easy one first. The easiest part to find is find the missing angle. So to find the missing angle, all we have to do is add the two angles together. 64 plus 82 is 146. Subtract from 180. I get that the missing angle is 34 degrees, and I want you to label that. That was angle B, and since it's an angle, you're going to use a big letter to label it. It's important that you distinguish between the big letters and the little letters. So that's one down, 2 pieces to go. The next thing we're going to have to find is we're going to have to find the first side. You can pick which side you want to find first. I would write that 34 we found in the picture. You can pick whichever side you want to find. So I'm going to go alphabetically. Let's find side A right now. Notice I'm calling that little a because it's across from big A. And then the setup for this is it's all about partnering things up that are across from each other. So if you looked back at the formula, it says sine big A over little a. The things across from each other go together. So it's going to be the sine of 64 over little a equal to, then you need to find another pair in the picture, and this pair has to have numbers for both of them. So it's going to be this pair that we use for the second equation, it's going to be the sine of 82 over 14. And then we just have to cross multiply and solve here since this is a proportion. It's going to be 14 times the sine of 64 equal to a times the sine of 82. And then to solve this, we're trying to get a by itself. We can divide that sine 82 all the way to the other side. And then the nice thing is your calculator does all the work. You're just going to type this in your calculator. We're going to get a is equal to 14 times the sine of 64 divided by the sine of 82. Make sure you use the fraction button on your calculator to separate the top and bottom. You get a is equal to 12.7. And we're not done yet. We still have one more part we need to find. We have to find that last missing side, which is across from big B, so it's going to be little b. So to find the last side, I'm going to start again by pairing those two together. This and the 34 and the b pair together because they're across from each other. So we're going to start with the angle first. Sine of 34, sine has to be followed by the angle, over the side b is equal to, we're going to use the same pair that we just used in the last problem. The reason I use the same pair is just so I'm not using an answer that I may have made a miscalculation on. I try and use the numbers that they already gave me in the problem. So then we cross multiply again. 14 times the sine of 34 is equal to b times the sine of 82. Divide by the sine of 82. And then type that in your calculator. This part right here, we type in our calculator, and you should get an answer of 7.9. All right, let's try another one. So again, first step is to draw out the picture. I'm going to go a little bit faster this time. It's triangle ABC, and we know that A is 40 degrees and C is 22.5 degrees, and little b that's going to go across from big B is 12. So if you look at the setup for this one, we have an angle, a side in the middle of it, and then an angle. So thinking back to when you did this in geometry, this is technically an angle side angle problem, which also tells us that this will work nicely with law of sines. It's going to be an easy, pretty straightforward, easy problem. So step one is, again, find the easy thing first. The missing angle is going to be super easy to find. All you have to do is add two numbers and subtract from 180. So if I add, I get 62.5. If I subtract from 180, I get 115. No, not 115, 117.5 degrees. And that is, make sure you label your answer, that's big B. That was the angle that was missing. So I'm going to write that in the picture because we're going to need that to solve for one of the missing sides. And then your next step is to find a missing side. So the missing side I'm going to choose is going to be little a. It's missing, let's try and find little a. Again, it's going to be across from big A, so make sure you put it in the right position. And it's going to be, if we partner that together, that goes with the 40. Sine of the 40-degree angle over the side A is equal to the sine of the pair we're going to use this time. We have to use the 117.5 over 12. And then again, it's just a proportion. Cross multiply. 12 times the sine of 40 is equal to a times the sine of 117.5. Get a by itself, so I'm going to divide by 117.5. Type that in your calculator. And this is your answer. It should be 8.7. And then the last part is to find the last side. So if we look back at the picture, we're missing the one across from big C, so we're missing little c. So it's going to be the sine of that angle across from it, 22.5 over little c, is equal to the sine of 117.5 over 12. Cross multiply. 12 times the sine of 22.5 is equal to c times the sine of 117.5. To get c by itself, we have to divide that sine to the other side. Divide by sine 117.5. And C is going to equal, whoops, wrong button. Type this in your calculator, and you should get that C equals 5.2.